There's no internet out here. How am I going to put this on my Instagram?
Does this seem like a familiar situation to you? If so, there's a solution. Ubiquitous satellite internet. Now that's 3 big words. Let's break it down a bit.
It's 2024 and our world's population is over 8 billion.
Despite this, only around 5 billion people use the internet.
Now where does that leave the other 3 billion counting? Well, the internet is a general purpose technology, meaning it has the potential for use by anyone to do just about anything. There are tons of questions around if access to it should be a human right. Access to it is life-changing. Imagine having high-speed internet wherever you go. Can we even have an equitable world if only some of us can use it? How do we even...
Before we get too theoretical, let's go back to explaining what the internet even is.
The internet is a massive network of computers, smartphones, and other devices talking to each other to share resources and information. When you send a message or access a web page, your device sends data packets across this network. The information is processed and a response is sent back to fulfill your request. That's the basics of the internet.
A satellite can be anything orbiting a planet. Even the moon counts as a satellite. But in this case, we're talking about artificial satellites, or technology we built and launched into orbit on a rocket. Depending on their mission, satellites can be found in various orbits, some close to Earth for detailed observations and communications, others much farther away, in geostationary orbit, staying over the same spot on Earth. There are many types of satellites, each designed for different tasks. Communication satellites help us talk to each other across the globe, transmitting TV, phone, and internet signals.
The last word, ubiquitous, means a widespread presence of something, kind of like a popular meme that gets everywhere.
Putting those 3 words together, ubiquitous satellite internet, means internet access from anywhere through a network of satellites circling the Earth.
Let that sink in. Access to the internet anywhere at any time. Imagine all the impacts that could have.
But what parts do we need? First, many satellites are connected together in a large constellation. At the beginning of 2024, the company Starlink had over 5,000 satellites in orbit, all networked together so they stay in the right place. They plan to eventually have over 40,000. Each satellite has to be launched into orbit on a rocket. USI isn't a whole new internet, it's just another way to access the internet we already have. So the new satellites need to connect to ground-based infrastructure like towers, cables, or antennas that connect to where customers are. Add up all the parts, satellites, rockets, ground-based towers, and wires, and there's a lot of parts and a lot of companies and governments involved. The sci-fi movie Geostorm spins a tale about how we use satellites in the future to control the weather.
There's potential for catastrophic weather events on a global scale.
In the movie, the satellite system is hijacked and millions of people are killed in extreme weather events.
I, on the other hand, have a mystery that I'd like to solve and prevent more deaths.
While satellites aren't even close to doing this now, the movie pushes us to think about the risks that come with a network of satellites and to be proactive in addressing them.
This may seem impossible now, but in the next decades, the capabilities of satellites could expand. Science fiction helps us to think about what could happen and how we can plan or prepare. The movie also has us consider the science behind satellite internet, such as how weather and solar radiation impact operations. Humans have been putting satellites in orbit since 1957. At first, only a handful of countries were launching them. Now, over 70 countries have satellites in orbit. From SpaceX to the United Nations, this global technology has a myriad of worldwide actors. Actors fall into 4 general categories: academic, government, nonprofit, and private companies.
Government organizations are responsible for regulating, funding, and writing policy on USI. The National Science Foundation provides funding for research, and the United Nations monitors international collaborations. Academic institutions are essential for education, testing, research, and development. Additionally, this video is a product of Arizona State University and an example of the university's involvement in USI. Nonprofits tackle everything from equity with USI to cross-sector collaboration. Mobile Citizen works on using the tech for education in developing countries.
The private sector is essential for constructing, launching, and operating satellite internet. Starlink is a well-known example that uses low Earth orbit satellites. As previously mentioned, in 2023, 2.6 billion people did not have access to the internet, and 53% of the world does not have access to high-speed broadband internet. This is a contributing factor to the digital divide, a concept referring to the gap in access to modern communication technology, such as the internet, laptops, or smartphones. The digital divide particularly affects people with lower income or less education.
Bridging access to the internet and other information and communication technology is needed to implement all 17 of the United Nations Sustainable Development Goals, which are targets for human well-being across the world.
Ubiquitous satellite internet promises to change this. It would get the internet to people who don't have it and also expand the range for current users. It is not meant to replace the land-based internet, but instead to expand access into remote and rural areas. Internet access isn't just for people, though. The Internet of Things is a network of devices embedded with sensors that allow the object to connect and send data with others over the internet. Almost anything, from your car to a potted plant, can get connected to the Internet of Things. This happens by using different technologies such as Wi-Fi, sensors, Bluetooth, or radio frequency to connect the objects to internet networks and infrastructure. USI would expand the Internet of Things, allowing for global data collection. More data could lead to better decisions making on the maintenance and operation of homes, cities, and forests, and oceans. On the other hand, expanding the Internet of Things could also mean data privacy issues, like companies selling customer data without clear consent. But this is where it's critical for the government to step in and set clear standards on how companies can use their customers' data.
But these goals come with challenges. Just making internet available doesn't mean everyone can use it. People need a phone, laptop, or other device, and a way to charge it. They also need to have enough money to pay for it all.
Plus, satellite dishes or phones need a direct view of the sky to efficiently operate. In ideal conditions, with no obstructions, a message would take 15 seconds to send. But send times could increase to over a minute if there are trees or other objects impeding the view.
Another big problem is that every satellite we launch on a rocket comes with environmental costs. The rocket fuel, plus all the minerals and plastics and other materials that make up all the parts. And once satellites are in orbit, they can get in the way of our view of the stars and other planets, or even collide with other satellites and objects, making an even bigger mess.
In the future, all of these problems are things societies can address together. Many people are actively working on it. For example, the UN works to get all nations on board with agreements about how we can use the internet in space.
They also work together with civil society to make sure everyone can access the internet, overcoming the challenges of wars, censorship, and resources.
On the research side, people are finding new ways to use sustainable energy and efficient technologies to lower environmental costs.
We can write code, develop standards, and put security in place so that the satellites and the ground-based infrastructure can communicate with reliability and security, and to keep all the objects in orbit from colliding with each other.
Governments also play a part in supporting innovation. For example, the United States has put the largest number of satellites in space so far, and the US government drives a lot of innovation by purchasing and regulating rockets, funding research and development, contracting with aerospace companies, and subsidizing new technology. The future of ubiquitous internet will merge satellite and ground-based infrastructure, tailoring to specific user needs. Getting all the people of Earth connected to the internet will require a combination of both. As technology improves, internet speed, reliability, and access will continue expanding. It could be possible for everyone to get connected by 2070 if we employ a mixed delivery approach.
But we ask you to think deeply about ubiquitous satellite internet, including the good and the bad. Think, what would the world look like if you could access the internet anywhere? What would it mean if we could collect data from around the world?
Ubiquitous satellite internet may bring us closer to fulfilling these promises, but at what cost? If you want to get there, we all need to work together so everyone, everywhere, can connect to the internet 24/7.